Let's look at question 59, spiral matrix 2. That question is a reverse question for the spiral matrix 1, 55. In this question, they give you the number from 1 to n squared that you fill into this matrix. So the little difference is in the first spiral matrix, the matrix size may different, but this is a square matrix, so the size is n. Okay, we just reuse the code from the spiral matrix question 1, and to save the time. In that question first, we need to create the matrix. So this one will be the new int n and n. So the high and width is n, so we can remove this one and remove the visited. And in that question, we know when Java created the array for the integer, so the default value will be 0. So we can think that all the initial value is 0. So if the value is not equal to the 0, so it means they are done. So we also need to change this one to the n. Okay, and here we also need to change it to the n. Same thing. If you have this value, it's not as equal to the 0, it means you need to fill this value, right? This is only different. So this one we do not need it. So we have the matrix. So we have a matrix. Okay, and matrix n and n. And we do not need this return value. In the finally, we return matrix. So we created the matrix and set this one to the C++. C initial value is 1. So we visit each matrix. If we are done, we break, we are finished. Otherwise, we fill the value. And then we depend on the director. If this director is go from the left to the right, so x is a plus. So if x minus n, so we need to change the direction to the going down, it's a y plus. If y plus is more than n, or we already fill the value before, we need to change the direction to the 2, and it's 2, 3. So finally, they will go to when you reach the 9, and the next one is 4 value is already be filled. So in that one, we do break, we are done. Okay, let's just run the code. Return matrix is typo. I think it's typo. Okay. And submit it. Yeah. The same idea to solve this question, use this direct. And because this is very go straight, the time complexity is n square, and the space is n square, big O of n square. Thank you for watching the video.